this is an augmented reality device I designed, and the goal is really to have a wearable display device, which is as small and light as possible. So I've been trying to reduce the power consumption so the battery can be smaller and lighter and still maintain a very high resolution display, because I want to be able to have complex user interfaces like you'd expect from your phone on a wearable like this. In current designs, and of course many past designs which didn't gain widespread adoption, often there were compromises made on the display technology, for instance, in order to get the battery life to be longer to reduce the power consumption. I'm trying to use several new and different tricks to still drive a high-resolution display and provide a rich user interface with much lower power consumption. And of course, when you lower the power consumption, the battery gets smaller and lighter, and then the whole device is smaller and lighter. So currently, I think the weight of this is about 29 grams, which is significantly less than pretty much anything else. And yeah, so you can feel it. And the display is a full HD 1920 by 1080 display, which is also so yeah, it's quite a niche technology, but this is also one of the more mature micro display technologies compared to what you find in some other headsets. So it's not terribly expensive, the display itself. Of course, then you have electronics and battery and so on.
Where's the display like this used?
So currently, beyond wearables like this, this technology, OLED on silicon, has been used in camera viewfinders. So like the Sony mirrorless cameras. Yeah, if you have an electronic viewfinder, if the viewfinder in typical SLR and DSLR cameras, the viewfinder has an optical path, right? But then Sony started making these so that they can just have a digital display as their viewfinder. So now, of course, Sony is marketing those products toward wearables like AR, VR. Yeah. So this display isn't made by Sony. This particular display is from a company doing them specifically for, wearables. So it's definitely a very, niche thing.
What MCU do you use?
So this is using a part from NXP Semiconductors. It's part of their IMX RT line. So these are kind of high-performance microcontrollers for user interface applications.
I worked on the RT1170.
Okay, very nice. The gigahertz one, yeah. Yeah, so this is the RT500. So it has a Cortex M33. It's like 300 megahertz, but you get a nice display controller, MIPI DSi, and a GPU. So you can do pretty impressive graphics stuff on a very low-power microcontroller. So that's really the motivation to put it in here.
Can I see the UI?
Yeah. So currently, the main goal, since you have sort of limited processing on the device, is to use a phone connected over Wi-Fi to do a lot of the processing and rendering. So I have basically a custom video codec for sending graphics from the phone to the device efficiently. So I had a demo where it mirrors the phone screen to the device to demonstrate that.
Is the idea to eventually make this like a Bluetooth connection, or?
So you could. It does use Wi-Fi currently to connect to the phone. The problem with Bluetooth currently is the data rate.
Latency, right?
Well, the other thing with Bluetooth is Bluetooth's not really suitable for doing any sort of high bandwidth graphics transmission. You maybe get 2 megabits per second at best with the 2M5, but that's also theoretical. You're not going to actually get it. So there's kind of a lack in high bandwidth personal area network technology right now. You have Bluetooth, you have Wi-Fi. Wi-Fi power consumption is at least like an order of magnitude more. So there's some promising technology in UWB. UWB is currently being used for direction finding, with the AirTags. There haven't really been a lot of data transmission applications of UWB yet, but I'm hoping that is eventually going to be a better sort of very short range, high bandwidth.
Anyone who's tried to game on Wi-Fi and then switch to like a Ethernet Ethernet cable.
Yeah.
Right?
And of course, you have people, wiring a headset to a phone in your pocket. But nobody's going to walk around all day with a physical wire, right? So here's some. Well, it just says "Hello World" currently. Right, and of course, optics design for people with glasses and such is a whole problem with which I have to consider.
Is the aim to bring a direct-to-consumer market product, or product to market?
You mean it's the intent to sell this right to consumers? Well, I mean, that's what everyone has been hoping for with AR, that it would eventually take off in that area. There have been so many attempts that failed in that regard, right? There are so many technical problems to be solved, really, and concerns about making it an actually useful device, not just some new gimmick, right?
Can I try it on?
Yeah, sure.
Their display is very tiny. This is full HD. Yeah. So perfect with this is actually that'd be even best. Similar aspects in the electronics to what you would find in